In this video, we're going to be calculating probabilities from a chart. So I'm not going to be covering any new ways of probability or new keywords. Instead, we're really focused in this video on just how to digest the information when it's presented to us in a large table, which usually, well, that will always mean that you have more information than you need. So the added challenge is figuring out how to pull the information you need out of a table. Okay, so here we go. Here's a table with some handy-dandy information about hot tea, because it's the best. And all the different ways you can have some different hot teas. So before we get to actually answering the question, I want to make sure that we're all reading the table the same way. And so basically, if you prefer to have if you prefer black tea and you don't want cream or sugar, you want neither of those, there are 15 people who were asked that like black tea, just black. However, there were 12 people who liked black tea with cream in it. So one of the things that's true of this table here is that it doesn't have the totals. Sometimes tables give you totals, sometimes they don't. And so if they don't, it's because they're made by a grumpy old person, and you should just go ahead and write the totals out. Some people try to just figure out what they need as they need it, but I promise you it's going to be more efficient to just write it out. So we're going to create a total column over here. And then add up all the sugar. So 21, 13, and 8, that's going to give us 42. 12, 5, and 6 will give us a 23. 17 and 3 give us a 20. And then 15, 16, and 9 give us a 40. I'm just going to go ahead and extend our lines because it'll make me happy. Alright, now we need a total in the other direction as well. It's good practice on our math skills. A little bit of adding never hurt anybody. So this first column is going to add to a 65. The second column adds to a 37. And the last column adds to a 23. Now in this box over here, what we want to put is the total. And so the total, both of the total columns should add to the same thing. In this case they do. It's 125. Now that we have those totals, we can go ahead and dive into some questions. So we've looked at several different types of probabilities. We've looked at just straight up probabilities. Like, what's the probability that someone will like black tea? You know, just a straight up probability. We've looked at ones with keywords with ors, and we've looked at ands, keyword ands. We've looked at conditional probability, and we've also looked at the probability of multiple events. So we could do all of those different kinds of probabilities with these tables. And then the challenge is knowing how to pull the numbers you need out of the problem. So let's just start with a straight up probability problem. What is the probability that someone chosen at random prefers black tea? Now this isn't specifying how they prefer their black tea. So anyone who likes black tea would count in this probability. So there are 65 of those. That's how many prefer black tea. That's going to go in our numerator of our probability, because the top number of probability is how many different ways the event that we're asking about could occur. And then the denominator of our probability is the total number of options. So our total number of options in the survey, 125 people was our total, so that'll be our denominator. So 65 out of 125 people would prefer black tea. Now, you can reduce that and express it as a fraction. If the problem asks you to express it as a decimal or percent, you can do the conversion, but the goal here is just to get you to see how to set up the original fraction. And I'll leave the reducing to you. I believe you can do it. Now let's look at an or probability. What is the probability that someone chosen at random prefers green tea or chamomile? So here our keyword is or. And as we talked about before, when we were talking about or, we're not saying that I can have green tea or chamomile. We're talking about potential attributes. So this person could like green tea, that works. They could like chamomile, that works. Both options work, and so with or we add. So our green tea likers, prefers, are 37. Our chamomile, people who prefer chamomile, is 23. So to get our numerator, we're going to add those numbers together to get the total number of people that likes one of those or the other or both. And then our denominator is still the total number. The total. It's going to give us 60 over 125. And then, of course, you can reduce that or express it as a decimal, whatever you prefer. It's not really whatever you prefer when you're working a math problem. It's what they tell you to do. But in life, it's whatever you prefer. So that's an OR, but I want to look at a different OR because there's two different ways these OR probabilities show up. So for part C, we'll look at what is the probability that someone chosen at random prefers green tea or some tea with sugar. Any of the teas with sugar. Alright, so our green tea number is still the 37. Now, any of the teas with sugar would be the 42. And like we saw before, we're going to add those together. So that would be 37 plus 42. Okay, now, but here's the weird thing with this OR. There are 13 people who like green tea with sugar. That 13 is in both the 37 and the 42, which means we've accounted for those people twice. And so this is where we have to subtract off that overlap. So that's how we're going to get our numerator. We take everybody who likes green tea, everybody who likes any of the teas with sugar, or prefers. I should say prefer, because you can like green tea with sugar and black tea with sugar. But this is about preference so that you get the singular result, because you can only have one favorite. Now, our denominator will still be the 125. So you do that math up and take it from there. If I'm doing it correctly, I'm getting 66 over 125. Alright, so that's a couple different ways that the OR can show up. And they're really the same problem, it's just the first OR didn't have any overlap. So anytime you have that keyword of OR, you're going to add things up, but you got to check to see if there's overlap in the things that you're adding up, and if there is, you have to subtract off the overlap. Alright, so for D, let's look at an AND probability. Now, when you're dealing with AND probability, it's important to note that this is one event. We're selecting one person, and I know that because it says, what is the probability that someone chosen at random? That's one thing happening. So our keyword is AND. And this is different than the probability of multiple events, and that uses the word AND as well. So you want to make sure you're dealing with one event here. So what's the probability that someone chosen at random prefers green tea and tea with sugar? Well, if they prefer green tea and tea with sugar, and is a limiting number. So we need to get a person that prefers green tea and tea with sugar, and so that's just going to be our 13 here. There are 13 people who were asked that prefer green tea and tea with sugar. So that's just going to be 13 over 125. The hard part there is remembering how to deal with the and we've been programmed to think that and means addition, and it doesn't in all cases. That's definitely an oversimplification of the and word. Here we want the person chosen to have both of these attributes, so that limits our options or expands our options, because you want to think of the or as an and or sort of thing. Okay, so for part E, we will jump to conditional probability. What is the probability that someone chosen at random prefers cream and sugar, given that they prefer black tea? Now notice here, I changed up the language just a little bit. I'm saying they prefer cream and sugar, but that's going to correspond to our both column. So the way that's represented on the chart is different than it's worded in the question, and so you gotta not be too confined in your thinking that the question will use the exact same word as what's in the table. Okay, so this given, sometimes this can be worded, that's our keyword for a conditional event. Sometimes that can be worded as assuming. You know, what's the probability that I draw a king, assuming I've already drawn a king and ate it. So that's the kind of thing we're looking at. Something has already happened, or I know some inside information that makes things a little bit more probable. So here we're saying what's the probability that someone chosen at random prefers cream and sugar, given that they prefer black tea. Now, if we know that they prefer black tea, that means we are only looking at the black tea column. So whatever comes in the given piece, or the assumed piece, or the hint that you're given, however that shows up, that is going to limit what you're looking at. You're not going to look at any other part of the table. So we're only looking at the black column. So there, now the number that preferred cream and sugar in that column is our 17. So that's going to be our numerator. Given that they prefer black tea, there are 17 of them that prefer cream and sugar. Now our total in our black column is the 65 there. So that's going to be our denominator. So this is the only probability that limits the denominator, is the conditional probability. Other than conditional probability, we're always looking at the total. So, well, probability multiple events can change the denominator for the subsequent fractions, but when you're dealing with one event, the only thing that's going to change the denominator is the conditional probability. So, given that, let's look at a probability of multiple events with this. What is the probability that two persons chosen at random prefer green tea without cream or sugar? So this is two events because we're choosing two people. So there's probability of choosing one of those persons, and then the probability of choosing the second person. You've probably done a lot of these with cards, like what's the probability of drawing a king and then a queen, or two kings is just like a wordier way of drawing two kings is what's the probability of drawing a king and then another king. But it's simpler when it's the same event twice. Alright, so to work this out, we need to find the probability of each event, and then once, I'm going to put a fraction bar for my probability, and then once we find those, we multiply them together to get our total probability. So we have two events here, so I'll have two fractions that I multiply together. If I had 5 events, I'd have 5 fractions that I multiply together, and so on. So, what's the probability of having one person chosen at random who prefers green tea without cream or sugar? Well, one person without cream or sugar, that's in the neither category, right? They prefer neither cream or sugar. Green tea, so there's 16 of those. So my numerator is going to be 16. My denominator is the 125, the total. Okay? And then I select that person, I set them over in a party hat to the left, and then I need to go select another one and hope, beyond hope, that I get one that likes green tea but without cream or sugar. So now my pool has changed because I've already taken someone out of my 125 and put them over to the left in a party hat. So now I only have 124. Now the person I put over to the side, over to the left with party hat, was one of my 16 because I'm selecting the same thing twice. So I'm going to bump this down to 15. And that's how you do that. Then you multiply them up with the assistance of your handy dandy calculator. When we do that, we get 240 over 15,500, and then we have to reduce that down, of course. Alright, so hopefully that helps you see how to kind of digest the information coming from a table like this, and hopefully it also helps you just review some of these different types of probabilities that we've been looking at. Give some of these a try and let me know how you fare.